How's everyone doing? My name is Carlos. I'm a web developer based in Brooklyn, New York. And today we're going to work on an off-platform project called Acme Bar and see how we can secure an application using different strategies and methods. So without further ado, let's go ahead and get started. Okay, so this is an off-platform project, meaning you will be working with your local environment and having everything set up on your local machine, which includes a terminal, a code editor, and a browser to work on. The application is called Acme Bank, and Acme Bank is a small credit union that provides assistance with deposit loans and a wide array of other financial services. Now, the web app is currently under construction, and the skeleton of it has been completed, but there are some vulnerabilities that were overlooked, so we're going to go ahead and take a look at how we can fix them and secure the application further. So we're going to be securing it by protecting it against XSS attacks using Helmet, securing cookies, validating and normalizing data with Express Validator, and implementing alternative methods to prevent DOM-based attacks. We're also going to be preventing SQL injection attacks by using SQL statements instead of hard-coding queries and validating input data. And lastly, we'll be preventing CSRF attacks by implementing the CSURF middleware and updating certain view pages to secure any cross-site request vulnerabilities. Now, for this project, you're gonna need Node installed. You're also gonna need a code editor and a browser ready to go, and you're gonna be using a DB browser called DB browser for your MacBook in order to navigate through the database. This application provides you with a .db file that has some records already in it, so you'll be using those records to use with the app. Okay, so first thing we're going to do, once you download the project, make sure to unzip it, open the folder and the code editor. I have already done that, so I'm going to go ahead and take a look at it. And here is our project. Will be displayed with an app.js file, some history files here, HTML folder, other node modules with all the packages that are needed. We'll have a public folder with the CSS and an images folder as well, and some view pages, which are including the EJS files. Our app.js file will be where the main chunk of our code lies, and here is where we'll have all of our requests. And our banksample.db file is not visible within the code editor. That's why we're going to be using DB browser. So you'll see that we have some packages here installed, and we have the SQLite 3 package using the database and connecting to this file here. We also have our application set up and a few things that are already set up for us and some routes. We have post auth in order to log in a user. We have the home page, the transfer page, the get request for the transfer page, the post request for the transfer page. We have the download page where we're actually going to be able to download some records. And that's about it. We have the public forum as well. And this is where we're going to be updating this file and adding some security and vulnerability. We also can take a look at some of the pages here where we have EJS. If you're not familiar with EJS, it's simply a template engine that combines JavaScript and HTML. You'll see right over here we use a special syntax in order to execute JavaScript code. We'll go over that a little bit later. So let's go ahead and see what we need to do. First thing we're going to do is type the command node app, and then we're going to open our browser to see the login page. Then we can go up into our DB browser and check out the .db file to see what tables are created there and what are the records that are within the database. Now you can use your external terminal. I'm going to use the one that's installed within VS Code. So I'll open up the terminal here and simply type node app. Now you'll see a little message here, which is logging out that the server is already running on port 3000. So we can go to the browser, go to localhost 3000, and you should see the app running on your browser. If we go here on our browser, you'll see that we have our login form here. Okay, now we can check out the DB browser to see what we have in our tables. So let's go ahead and open DB browser here. If you click on open database and navigate to the folder where your DB file exists, you can double click on it and then it should open up the tables and with all the records. Here I've already navigated into the actual folder and you'll see our bank underscore sample.db file. So if we double click it, it should open it for us, and then we'll see here the tables that are created for us. We have the public forum, a table for the ledger, some users. You can click on browse data to see what exists, what records are in each table. What we're interested here is on the users in order to log in. So we'll see that we have a username and a password here. Now, ideally, in an actual full deployed production application, these passwords would actually be encrypted, either hashed in some way so that they're not stored in plain text, because these are very vulnerable. But for now, we're going to be working with plain text passwords. So we know that the password for this user is right over here. I'm going to grab that, and we know that the username is admin. So let's go back into our browser and try to log in with that password. Once logged in, it should redirect us to the homepage, and now we have access to the application. So feel free to navigate through a few of the sites right now. You should be able to access most of them. If some of them are inaccessible, we'll probably be updating them as we go through the application, but you'll see that we have links to transfer funds, to download our records, to check out the public ledger, and to go into the public forum. We'll always see certain posts from other users. So back into the instructions, let's go ahead and take a look at what we need to do next. So we'll be protecting against XSS attacks now. Now, the way the application is currently built, it will expose a lot of vulnerabilities to different kinds of cross-site scripting attacks, particularly in the forum where users can upload code via the comment box. So we're going to be adding layers of security to prevent any of these attacks. So if we take a look at our code here and scroll into the public forum request right over here, we'll see that we're actually inserting the username with a message into our database. Now here's a vulnerability just in case someone else kind of manipulates the way we're inserting things into this backend server. They can use a form, the input field, in order to insert SQL queries and then alter our table so it executes certain code whenever someone else requests it. So if we take a look at the way our application is built at the moment and we go into the public forum, when we go into this page, we're actually requesting these messages here. We're retrieving them from the database. So if someone were to actually insert SQL code here, that can be very problematic into the app. Whenever we request those messages, that code would be executed when we access this page, and therefore it could be malignant to the user accessing it. So we need to make sure that whenever someone submits a post into this particular page here, they're not able to add any other code other than the admin and the actual message. So we're going to be securing this in a moment here. You'll also see certain console logs here just to make sure that we're actually retrieving and passing in proper information. Here we're actually console logging any errors that are possible and any messages from the database itself. We're going to be securing our headers now. And in order to do this, we're going to require the helmet package and implement the middleware. Now, the helmet package is already included in our package.json file, so we don't need to do npm install helmet. All we need to do is require it in our code editor and then simply make the call to helmet when we use the middleware. Back in here in our app file, let's go to the top here. And right here, we'll do const helmet equals require helmet. Now we can put this anywhere. I'm going to put it right here under the static middleware. So app.use helmet. And now we are securing our headers. Make sure you save this. Whenever you save your app.js file, you make sure you restart the server. There is one other package you could use as well called Nodemon, which is a hot reloader. This is optional. I'm going to use it just so that we can go through the project a little faster. If you're on your own, make sure you take your time and restart the app in case you find any errors. But Nodemon will basically restart our server anytime there are changes into a backend file. So I'll use Nodemon app, nodemon.js, and now it's starting. So anytime we save our JS file here, it will restart the server. Okay, so let's go back into the instructions here. Now that we have our header secured, we can go into the next step. So now we can sanitize and validate inputs on the public forum. We're going to be using the Express Validator package in order to sanitize and validate any input data. So this will prevent an attacker from manipulating data before it reaches our database. So we already have Express Validator installed. What we're going to do is require the package and then go into the post request for public forum, and we're going to have validating the comment that's coming in from the request. We'll be using escape because it essentially converts any characters used in HTML to their equivalent HTML entities. So let's go ahead into our code here, and at the top of the file, we'll add Express Validator. I'm going to call this validator. Require Express Validator. And we'll scroll down here to our post request for the public forum. And right where we're receiving here the request.body.comment, we'll use our validator. And it has our built-in function here called escape. And then we can pass in the request.body.comment. And with this implemented, we will prevent anyone from injecting any kind of SQL code into our database. Okay, let's move on. Okay, we're going to do a little bit more of SQL injection protection here by updating our post request for /auth, which is currently vulnerable to SQL injections. So we're going to be updating our SQL query to use prepared statements instead of string interpolation for the username and password. So let's go here. Let's go up towards our auth request here. Let me try to find, here we go, for our auth request. You'll see here that we're using string interpolation in order to pass in the request.body.username. This can be tricky just in case they alter the way they're passing in the username. So instead of doing this, we're going to use prepared statements. Instead of using string interpolation here, all we need to do is use the question mark here, and this will find a variable passed in brackets. As you can see here in the example, all we need to do is simply add a comma here and add in username and password. So these are the variables that will be looked for. Make sure you add a comma as well after brackets. So the username will be replacing the username variable, and same with the password. This will protect the login SQL from any other possible SQL injection. Make sure you save your file, and we can move on. Okay, we're going to address another vulnerability at the public forum. Right now, we also have the similar issue by using SQL parameters and for the request query, comment, and username. So let's go back down to the public forum. And make sure you go to the post request here. And you'll see we have a similar type of, it's not exactly using string interpolation, but we want to replace this by using the actual prepared statements. So instead of using the string interpolation here, what we're going to be using is replacing them with 2 question marks and then adding the same thing we had previously. So username first and then comment. We're using comment because that's the name of the variable that was used above here. And remember that the order is important because username will be the first value that we're inserting, and the second value will be the one that's being inserted here. So first we want username, and then we want comment. Perfect. Okay, that is it for the public forum. Let's go ahead further and address another vulnerability in the public ledger page. Users can actually take advantage of the search query to inject SQL queries. So we're going to go ahead and protect the GET request for public ledger by using SQL parameters for the request queries ID and amount. And we're going to make sure we parse the value for the amount to make sure that it's an integer and not a string when it's inserted into our database. So we go here, we go to the public ledger. We'll see here that we have a list of results with senders and recipients and the amount that was sent. And here is our search query where people can actually insert some SQL queries here into our table. So instead of doing that, we're going to make sure we validate and sanitize the data before it reaches the backend. So back in our code here, let's go into the request for the public ledger here. Seem to have lost it. Here we go, public ledger. First thing we want to do is to make sure that we're parsing the integer for the request query ID. And the next thing we're going to do is simply replace this string interpolation with the question mark as we've been doing before, passing in the question mark. Oops, right here. Adding in brackets the variable that we want to check, which will be ID. And now we have our public ledger secured with from SQL queries, and we're making sure that the ID is an actual integer. Okay, let's move further to the CSRF prevention. Now we've successfully protected our app from cross-site scripting attacks and SQL injections, but we've yet to secure it from attackers running our session via the CSRF attack. So we're going to require a package called CSURF and the cookie parser packages, and store them in two variables called CSURF and cookie parser. So at the top of our file here, let's go ahead and install it, and believe we want to store them in variables called CSURF and cookie parser respectively. So const CSURF equals require CSURF, and we'll call this cookie parser, requiring cookie parser. Now we're going to set up the cookie parser to use the CSURF token. Now when we do this with our cookies, we usually have them stored in a session here, and we already have Express Session installed and kind of set up right over here. So we're going to create our cookie and make sure to use our cookie parser with the CSURF token there available for us. So now we can set up the middleware. Now, when we set up the middleware for cookie parser, we got to make sure that we call it. So I'm just going to grab this line over here and put it right below our JSON middleware. Make sure you save your file. Let's move forward. Now we're going to configure our middleware for the CSRF package. In order to do this, we're going to create a variable called CSRF middleware, and we're going to assign it to the configuration of the cookie. We're using the same set to none. And we're going to make sure to use this inside an object here. So let's create the middleware. Create it above all your requests. So I'm going to create it right over here. CSRF. Sorry, CSURF, I believe, yeah. We'll create an object here. We'll set the object of the cookie. We'll make sure the property is same site is set to none. And save your file. Okay, now we can move on. Now we're going to create a middleware to add to a specific endpoint here. And there are a few steps for this middleware. We're going to be checking the property code is equal to this following string, which is generated from the CSURF package. And if it is, we're going to send the status code of 403 along with the message of the EBAD CSRF token. We're going to be using an if-else statement in order to handle logic to make sure that the name parameters error and next are used. Okay, so when creating middlewares, they essentially have the same kind of syntax and format to them. We can use app.use to create the middleware here, and we're going to set up a callback function here. Now the order of these variables are important. We're going to be passing error first, request, response, and lastly next, and then we can create the arrow function here to create our middleware. So like the instructions said, we can use an if-else statement. So I'll create the skeleton for that here. Now, if everything works correctly, we want to make sure that we pass in the call function to next, which will basically pass in the execution to the next endpoint here. What we want to check here is if the error code is equal to the string that was sent to us here, which is the EBAD CSRF token. And this would be stored in the property .code. So we want to make sure if that equals to, oh, sorry, I added two strings here. If that equals to EBAD CSRF token, then we're going to execute some code, which will be the status code of 403. Yep, 403 along with the message EBAD CSRF token. You can be a little bit more descriptive in the message. We can simply say the token was invalid. So this will make sure that whenever a user makes a request, it'll check that the code, the request that it's being sent from has the CSRF token. And if so, it will execute the next command and give back the actual page the user is trying to access. So make sure you save your file here. And now we're going to be making use of this middleware. Now for the get and post request for transfer, we're going to add the CSRF middleware before continuing with the request. So let's scroll to the transfer endpoints. Right down here, we have the get request and the post request, and we are being instructed to add the CSRF code. When adding some middleware into an endpoint, all we have to do is simply pass the middleware before the actual request response callback here. So we can simply add CSRF middleware, and we'll do the same for the post request here. Let's save that. But now we got to make use of the CSRF token in our view pages. So let's go to our transfer.ejs file here. Now, where exactly are we going to be adding our CSRF token? Well, if we look into the actual view page to see what it looks like, we'll see that we have the input field here, and we want the CSRF token to be attached when we submit this form, right? But we don't want it to be visible for the user. So what we can do is hide it from the user. And actually, I think this is in transfers.ejs, not transfer. Yes. This is when we're actually sending the form with a post request here. So in here, where we have an input with the amount, we can add the CSRF token here. So I'm going to be adding an input tag here. Input. We're going to be adding a name of _CSRF. Let's make sure the type is hidden so that it doesn't show in the actual form. And the value, well, we're going to have to actually pass in the CSRF token into this request page. And we can do that by going into our app here, going to the post request for transfers. The get request for transfers. And here we're, instead of just sending sent, we can add an actual variable which will be retrievable when we get access the EJS file. So we'll call it CSRF token. And this can be retrieved by actually making a function call within request. So if you make a call to request.csrf token, you'll see that this function is exposed to us by implementing the CSRF token variable. So the package, I mean. So once that is created, the request will create the token itself, attach it to this variable that's being sent back into the EJS file, and then we can actually render that token here as the value. So in EJS, if you want to actually display the actual value of JavaScript, we can simply add an equal sign and then the variable name. In this case, it would be CSRF token. And with that, we've successfully secured our application from with CSRF token. So now if an attacker tries to send a request and there is no CSRF token, then the middleware will be executed and it will stop the execution of the next piece of code. Okay, let's move on to the next part. We're going to be using the path traversal protection. So in the post request for download, we have an endpoint that allows you to download personal records. Let's go down here. Here we have the download post request. We're actually grabbing the request body file. So let's go into the actual page here. See what it looks like. Let's go back here. Let's go to download your records. When we click on this button here, we'll make a request to this endpoint, which would take the file name, store it in a variable called file name, and then essentially download the file for us locally. Now, someone can manipulate the way we're actually retrieving this file due to the way we're setting the current directory. Instead of using a hard code here, we want to actually use the file package, the fs package, in order to traverse the root folder for where this file lies and retrieve it accurately instead of just having it being hard coded. Now there are a few steps to this, so let's go one by one. So first thing we're gonna do is simply get the correct file path instead of just hard coding this. So let me just comment this out for a second here. We're set the file path to the actual working directory using the path method. So let's assign it to path.join, which will take in a few parameters here, where it will join all the arguments together and normalize the resulting path. So what we want is the current working directory. So we can do that by simply typing process.cwd, and make sure you call it. Then next thing we want to add is /history files, because that's the name of our folder here. And next thing we'll add is the file name variable, which we have right here, which is the file that's from the request body. So let's delete this. We still want to normalize the file path in order for it to be retrieved correctly. I'm sorry, the file name. So we'll create a new variable called file name. And we'll use the normalize function here, which essentially removes unnecessary parts when there's multiple slashes or anything that's being replaced by a single one. So normalize will pass in a file path here, and that will normalize the actual file path. Save that. We also need access to the actual root directory, and we're going to be looking for the root directory when we try to retrieve the specific file. So let's make another variable here on top of file path called root directory. Let's set it equal to history files, because that's where we're going to be adding the files, and we're at 2 slashes in order to actually escape any unnecessary strings. Make sure when you add the header variables, you do them all the way here at the bottom. Oh, and these should be escape brackets here, escape slashes. Okay, perfect. This is looking good. So right here where we actually attempt to download a file is want to check that the file name exists within our root directory. So we got to make sure that it is part of the root directory, which is history files here. So we can do this using an if-else statement. If the actual the file name exists within the root directory, then we'll actually read the files synchronously and then send it over. Otherwise, we don't. Or we could do it the other way around. Let's actually do it the other way around, where if the file name does not exist within the root directory, we'll send a message that says file not found. So how can we do this? Well, there are various ways. We can simply use index auth and check if this string here exists within the root directory string. So if file name exists within root directory, meaning if it does exist, then we'll execute whatever comes up after the else statement. If it doesn't, the value will be less than 1. So we can check that by doing less than 0. If the file name does not exist in the root directory, within the root directory, then the value will be -1, and we execute the code within these curly brackets. So in here, we can simply do response.end file not found. We'll save that. Otherwise, we can simply add this code here. And there we go. We have now secure our path traversal for when we want to download a folder. Okay, and that mostly completes the way we are securing our application using different methods and strategies, from cross-site scripting attacks, SQL injections, and using the CSRF token. Now we can add a linter to make sure that everything is properly formatted. Here are a few instructions on how to do it. We can simply install the ESLint package. So let's go back into our app here. Let's close this and add the code here. Oh, it seems like I added the call. npm install /dev ESLint, and let's install it. npm install ESLint /save dev. So it installs it as a developer dependency. Once that is installed, we can take a look at what to do next here. From here, we can configure ESLint with the following command, and this should create an ESLint RC file for us. So let's add it here. We want to check the syntax and find problems. We're simply using CommonJS, which is using require. We're not using React Review. Does your project use TypeScript? No. And we're running our code on the browser. We're checking for format, JavaScript, and here we have our ESLint.rc.js file. Once we have our ESLint.rc file, we can configure it with any of the rules that we want and make sure that everything is formatted properly. So you might see a couple of errors here. This is simply the ESLint reacting to the way your rules are set. Right now it's kind of blank. But yeah, we've successfully were able to secure Acme Bank. If you had trouble, make sure you maybe go over this walkthrough once again. Now you'll see that there are various ways an attacker can penetrate a site and retrieve important data. So it's always important to take different measures when we secure an application, since there's no silver bullets. Make sure your HTTP headers are secured. Make sure to validate and sanitize data and use the prepared SQL statements along with any static analysis tools like the ESLinter, and also implements different types of middleware to make sure that you handle any errors and kind of see a couple of steps forward of how an attacker might penetrate your site. So thank you all for watching, and I'll see you all next time.